first time, astrophysicist Avi Loeb has suggested the object has alien origins. He came on this show to say so.
It was discovered using their telescope at Rio Hurtado in Chile, and it was first detected as a speck of light moving relative to background stars.
Something from beyond our solar system just revealed itself, and what the James Webb Space Telescope uncovered is raising serious alarms. 3I Atlas was expected to be a quick visitor, strange but understandable. Instead, its behavior broke the rules. The chemistry did not match. The activity should not exist. And the deeper scientists looked, the more uncomfortable the answers became. This is not just a rare cosmic visitor. It may be evidence that we understand far less about the universe than we thought. The rare visitor far from beyond. On a quiet night in early July, astronomers spotted something that did not belong here. On July 1st, 2025, the Atlas telescope in Chile picked up a fast-moving object slicing through space on a strange path. It was quickly named 3I Atlas, also known as C2025N1.
We've got a big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system.
And almost immediately, scientists realized this was no ordinary comet. This was only the third confirmed interstellar visitor humanity has ever seen, following the baffling arrival of Oumuamua in 2017 and the dusty traveler 2I Borisov in 2019. What makes 3I Atlas so special is not just where it came from, but how it moves. This object is racing through our solar system at roughly 58 to 60 kilometers per second, far faster than most familiar comets. Its trajectory is hyperbolic, which is science's way of saying this thing is not sticking around. It is passing through once and will never return, continuing its journey back into deep space after a brief visit. There is no second chance to study it, no rewind button. Miss it now and it is gone forever. That alone would make 3I Atlas a big deal, but the deeper meaning runs even further. This object is made of material formed around another star, in another planetary system, possibly billions of years ago. It is a physical fragment of a place we have never seen, drifting straight through our cosmic neighborhood. And just when researchers thought they understood what kind of visitor this was, the James Webb Space Telescope took a closer look, and everything changed. Webb captures the unthinkable.
This is a worldwide telescope all these countries are willing to make to reach the edge of the universe.
When the James Webb Space Telescope turned its gaze toward 3I Atlas on August 6, 2025, astronomers knew they were in for something special, but they weren't prepared for just how strange this visitor truly was. Using its near-infrared spectrograph, or NIRSpec, Webb could detect light and chemical signals invisible to any other telescope, revealing a level of detail that changed the story completely. The data coming in was unlike anything seen in comets from our own solar system. What shocked scientists first was the chemical makeup of the comet's coma, the cloud of gas and dust surrounding its nucleus. Carbon dioxide dominated in a way that left researchers scrambling to double-check their results. The CO2 to H2O ratio was roughly 8:1, meaning this comet had 8 times more carbon dioxide than water. Typical solar system comets like Halley's have water to CO2 ratios of 10:1 or higher, with water as the dominant component. 3I Atlas completely reverses this pattern. Alongside carbon dioxide, Webb also detected smaller amounts of water vapor, carbon monoxide, carbonyl sulfide, and even traces of dust and nickel embedded in the icy cloud. Every single one of these readings told a story of a comet that was not just foreign, but possibly formed under conditions radically different from anything we see in our own neighborhood.
Cometary tail around it, no dust, no gas, so the question was, what is pushing it? Maybe it's the reflection of sunlight.
The implications were staggering. Comets in the solar system are essentially frozen relics from the sun's early days, dominated by water ice. 3I Atlas's carbon dioxide dominance suggests it formed under entirely different conditions, possibly in a colder region of its parent star system or around a star with different chemistry than our Sun. This wasn't just another icy rock wandering through, it was a sample from an alien environment, one that had preserved its secrets for who knows how many millions or billions of years. Even as scientists tried to make sense of it, Webb's data raised more questions than answers. How did a comet form with such extreme CO2 dominance? Was it shaped by radiation from its parent star, or did it come from a colder region far from its sun? The mystery deepened with every frame, every spectrum, and every calculation. And this was just the beginning. Webb's revelations were not only rewriting what we know about interstellar comets, but also hinting at a story of origins far beyond our solar system. Next, we explore exactly where 3I Atlas might have come from, and why its birthplace may be as strange as the comet itself.
Mutual attraction between the two objects slowly tugged the asteroid off of the impacting trajectory.
Where 3I Atlas might have been born. The strange chemical fingerprint of 3I Atlas immediately sparked questions about its origins. How does a comet end up almost bursting with carbon dioxide while barely carrying water?
The plume of gas around it is mostly carbon dioxide, 95% by mass, based on the Webb telescope data.
Astronomers suggest that the answer lies in its home system far beyond our own. Extreme levels of CO2 hint that this comet may have formed near what scientists call the carbon dioxide ice line, a region in a star system cold enough for carbon dioxide to freeze solid. Comets forming in this zone would naturally trap more CO2 than water, giving 3I Atlas the unusual composition we see today. But the story does not end there. Researchers also suspect that 3I Atlas may have been exposed to intense radiation before leaving its birth system. That radiation could have altered its chemistry in subtle ways, stripping some molecules and enhancing others, effectively reshaping the comet during its early life. High-energy particles from its parent star may have altered the comet's surface chemistry before it was ejected into interstellar space. Every molecule and every ice grain becomes a clue to the conditions that existed far away, billions of miles from the Sun. Compared to comets in our solar system, 3I Atlas is almost unrecognizable. Typical comets are dominated by water ice with traces of dust and frozen gases like carbon monoxide. This alien visitor flips that expectation on its head, defying the models astronomers have spent decades refining. It is as if nature was experimenting with a recipe entirely unknown to us, and 3I Atlas is the first sample that made its way here. All of this raises bigger questions. If its chemistry is so different, what does that tell us about the diversity of planetary systems in our galaxy? Could other stars produce comets we would barely recognize? And more immediately, how will this strange chemistry affect the comet's behavior as it moves closer to the Sun? Because 3I Atlas's makeup is not just a static record of its birthplace, it is also a clue to the next mystery, the unusual ways it reacts and releases gas while approaching our Sun. That behavior turns out to be just as bizarre as its alien chemistry. Activity where none should be. As 3I Atlas continued its journey through the solar system, astronomers noticed something. Ultraviolet observations revealed clear signs of water activity, known as OH emission, even when the comet was far from the Sun, well beyond the distance where water normally begins to sublimate. This was surprising because comets are usually dormant at such extreme distances, their icy surfaces frozen solid and largely inactive. The fact that 3I Atlas was showing water activity so far out suggests that there is more going on beneath the surface. Scientists believe this could mean the comet carries large icy grains that slowly release water, or that its surface is unusually active, exposing volatile materials in ways typical comets do not. This behavior confirms that 3I Atlas is not just chemically unusual. Its activity shows that it responds differently to solar heat and radiation compared to the comets we are familiar with. The comet's behavior raises new questions about how it formed and what kind of environment it experienced in its original star system. Its outgassing patterns suggest that there is more to learn from this interstellar visitor than just its chemical composition. While the chemistry and activity of 3I Atlas are already fascinating, they are only part of the story. Its shape and the strange ways it moves and ejects material are just as unusual, setting the stage for discoveries that could challenge everything we thought we knew about comets. Wheeling jets and strange structures. As 3I Atlas hurtled through the solar system, astronomers noticed yet another oddity that set this comet apart from anything they had seen before. Ground-based telescopes began picking up strange patterns in its coma, the cloud of gas and dust surrounding its nucleus. Instead of a simple tail streaming away from the sun, 3I Atlas displayed wobbling jets that seemed to twist and turn unpredictably. Even more bizarre were rare anti-tails with streams of dust pointing directly toward the sun. This violates basic physics. Radiation pressure from sunlight pushes dust away from stars, which is why comet tails point away from the sun. While anti-tails can appear due to viewing geometry when Earth crosses a comet's orbital plane, the structures in 3I Atlas suggested more complex internal dynamics. Scientists quickly realized that these unusual jets challenged everything they thought they knew about comet behavior. In typical comets, tails and jets are driven by heat from the sun, causing gas and dust to sublimate from the surface. These flows usually shoot outward in a relatively predictable pattern, forming the iconic tail pointing away from the sun. But 3I Atlas was breaking the rules. Jets bending toward the sun suggested complex internal dynamics or rotational effects that even experienced comet researchers could not fully explain. The comet was showing signs of processes that might be entirely unfamiliar to us, or at least much more active than any comet in our own solar system.
There's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
Each wobble and twist in the jets became a clue. They hinted at variations in surface composition, uneven heating, or internal structures that directed the flow of gas and dust in unexpected ways. The anti-tails were particularly revealing because they suggested that dust particles were not simply being blown off the surface. They were interacting with forces in a manner that could only come from unusual geometry or internal activity. In short, 3I Atlas was not just a frozen visitor, it was a dynamic, constantly changing object with secrets to reveal about how interstellar comets might behave. What made this even more intriguing was that these jets and unusual structures could be linked to the comet's chemical composition. The extreme carbon dioxide levels and traces of other exotic compounds could be driving outgassing in ways completely unlike the water-dominated comets we are used to studying. Every observation seemed to deepen the mystery, showing that 3I Atlas was more than an oddity. It was a challenge to our understanding of how comets form and evolve. And while the wobbling jets and anti-tails told one story, the next set of high-resolution images from Webb and Hubble promised to uncover the comet's structure in even more detail, adding another layer of mystery to this extraordinary visitor from another star system. Visualizing the alien visitor. As 3I Atlas continued its rapid journey through the solar system, astronomers turned both the Hubble and James Webb Space Telescopes toward it, hoping to capture as much detail as possible. Hubble delivered high-resolution images that revealed the comet's dust plume stretching outward from the nucleus. The images allowed scientists to see the fine structure of the coma.
The jets associated with 3I Atlas display persistent geometry and symmetry.
The cloud of gas and dust surrounding the icy core. Estimating the size of 3I Atlas was a challenge because its diffuse coma makes the nucleus difficult to measure directly. Based on visible light and dust models, scientists put its diameter somewhere between 320 meters and 5.6 kilometers. This wide range exists because the nucleus is hidden within the coma. Scientists estimate size from brightness, but the unusual dust properties and extreme CO2 outgassing make standard models unreliable. That range is wide, but even the smallest estimate makes it a substantial object, capable of carrying an enormous amount of frozen material across the galaxy. Every measurement is another clue to its origin and the conditions it experienced before arriving in our solar system. By combining Hubble's sharp visual imaging with Webb's infrared data, astronomers gained a much more complete picture than either telescope could provide alone. Webb revealed the chemical makeup of the coma, showing carbon dioxide dominance and traces of other exotic compounds, while Hubble provided a detailed view of the dust structures and jets. Together, the two data sets allowed scientists to see how the composition of the nucleus interacts with the surrounding dust, creating the strange patterns and wobbling jets that had already puzzled researchers. These composite observations are more than just pictures. They provide a window into the comet's physical and chemical behavior, offering clues about the internal processes that drive its activity. Even with these incredible images, the comet remains unpredictable. and the data raises as many questions as it answers. Visuals alone cannot tell the whole story. The numbers behind 3I Atlas, from its extreme speed to the unusual chemical ratios, reveal a visitor unlike anything in our solar system. Understanding what these numbers mean could rewrite what scientists thought they knew about comets, interstellar objects, and the diversity of planetary systems across the galaxy.
We cannot really pinpoint the nucleus size. It's partially due to the size of the object, but also it's partially due to the activity.
Numbers that defy expectations. 3I Atlas is not just unusual in appearance or chemistry. Its activity rates tell a remarkable story. Its dust and gas output is unlike anything seen in familiar comets. Observations indicate that it loses about 130 kilograms of carbon dioxide every second, while releasing only about 6.6 kilograms of water in the same period. That is an extreme imbalance, far beyond what is typical in comets formed around the Sun, where water usually dominates. This CO2-heavy outgassing is one of the reasons scientists think the comet formed in a very different environment. The materials inside the comet are just as intriguing. Scientists have detected traces of nickel and sulfur compounds, hinting at a chemical diversity that is unusual for comets in our solar system. These compounds suggest that the comet's original star system had a very different chemistry from our own, and that 3I Atlas has carried this alien fingerprint intact across light years of space. Every piece of material adds to the mystery, providing insight into how planetary systems beyond our own might form and evolve. With numbers this strange, it is easy to jump to wild speculation. Some have wondered if 3I Atlas could be artificial or the result of some unknown phenomenon. Scientists, however, are approaching the comet with caution. They carefully investigate every anomaly, focusing on natural explanations first, while acknowledging that this interstellar visitor continues to challenge everything they thought they knew about comets. 3I Atlas is more than a fast-moving chunk of ice and dust. Its extreme speed, unusual outgassing, and unique chemical composition make it a messenger from another star system. Understanding these numbers may not only explain the comet itself, but also offer a rare glimpse into the variety and complexity of planetary systems across the galaxy. How scientists are responding.
It was the very first object that we had ever discovered that had originated outside the solar system.
The unusual observations prompted astronomers to turn to the Green Bank telescope in search for technosignatures or signals that might indicate artificial activity. So far, nothing has been found. There is no evidence of alien transmissions, no blinking lights, and no hidden messages in the data. The comet remains, for now, entirely natural in origin. Even with the lack of any signs of artificial interference, scientists are cautious. They stress that, while 3I Atlas behaves in ways we have never seen before, every observation so far can be explained by natural processes. The comet's extreme carbon dioxide output, its wobbling jets, and its unusual outgassing patterns all fit into scenarios involving unusual chemistry, rotation, or internal activity. Researchers are careful not to jump to conclusions and are instead studying the comet with an open mind, letting the data guide them. The debate exists because 3I Atlas truly challenges existing comet models. In our solar system, comets are mostly water-rich and produce relatively predictable tails and jets when heated by the sun. This interstellar visitor behaves differently at every turn. The extreme CO2 dominance suggests formation in a very different environment, while the jets bending toward the sun hint at complex internal dynamics. No comet in our own neighborhood has shown such a combination of features, which makes 3I Atlas both fascinating and confounding. Scientists are now carefully weighing every piece of evidence, running simulations, and comparing the comet to Oumuamua and 2I Borisov, the only other confirmed interstellar objects. Each analysis helps narrow down the possibilities, while the unusual features keep the discussion alive. Even with all the data in hand, 3I Atlas remains a mystery. Its behavior and chemistry are ambiguous enough to keep astronomers intrigued and the public captivated. With intense scrutiny continuing from telescopes around the world, everyone is left wondering what secrets this visitor will reveal before it disappears into the depths of space. Race against time.
observing this rare comet that had water vapor in it. They saw it in our solar system.
By late 2025, 3I Atlas had reached its closest approach to both Earth and the Sun. It was a fleeting moment, a brief window when astronomers could study the comet up close before it raced back into interstellar space. At its closest, the comet was visible through a range of telescopes, providing an opportunity to capture images, spectra, and data that might never be obtainable again. Every observation was precious because once it passed, 3I Atlas would be gone, leaving only the traces it had left behind. Scientists around the world mobilized quickly, coordinating observations from ground-based telescopes, space-based platforms, and radio observatories. Every piece of information mattered. High-resolution imaging, chemical analysis, and dust measurements were being collected as fast as possible. The comet's extreme speed meant that the window to study its behavior and composition was extremely limited. Researchers had to act fast, making split-second decisions on what instruments to use and which aspects of the comet to prioritize. It was a race against time in the truest sense, with the universe dictating the schedule. Some teams even proposed more ambitious efforts. Ideas were floated about sending spacecraft through the comet's tail to directly sample dust and gas. These missions would be unprecedented, offering a chance to physically analyze material from another star system. However, the time constraints made any such mission extremely challenging. Launching a spacecraft, navigating to meet a fast-moving interstellar object, and collecting samples in a matter of months is a logistical and engineering feat that might push the limits of current technology. Even so, the fact that such proposals were considered highlights just how unique 3I Atlas is. Every observation, every measurement, every calculation during this period added a new layer of understanding. Scientists were not just watching a comet, they were watching a messenger from another star system. Its fleeting presence demanded focus, precision, and speed. And while the comet is now leaving, disappearing into the vast reaches of space, the data collected during its brief visit will continue to provide insight for years to come. 3. I-Atlas is more than an interstellar visitor. It is a rare opportunity to learn about how other star systems form comets, how alien materials behave, and ultimately, what this reveals about our place in the cosmos. The race to study it may be over, but the lessons it carries are only beginning to be understood. What this means for our understanding of the universe. 3. I-Atlas may have left our immediate neighborhood, but its visit is already changing the way scientists think about the universe. Its unusual chemical makeup and extreme carbon dioxide dominance suggest that planetary systems elsewhere in the galaxy can produce bodies very different from the comets we are used to. Until now, astronomers largely assumed that comets shared similar compositions because the physical processes forming them in our solar system seemed consistent. This interstellar visitor challenges that assumption completely. It is a clear reminder that the galaxy is far more diverse than we often imagine, and that other stars may give rise to objects with entirely unexpected properties. The implications for comet science are enormous. If comets are not uniform, then each one is a window into the environment where it formed. Water-rich comets, carbon dioxide-dominated comets, and perhaps other chemical variations all carry the signatures of their home systems. They tell stories about the temperature, radiation levels, and chemical ingredients present when they were born. 3I Atlas is essentially a physical record of another star system's history, offering information that cannot be gleaned from telescopes alone or from studying our local comets. Every molecule and ice grain holds clues about the physics and chemistry at play millions or even billions of miles from the Sun. Beyond chemistry, 3I Atlas offers a rare chance to study how alien objects behave in our solar system. Its wobbling jets, anti-tails, unusual outgassing, and rapid speed all reveal processes that challenge existing models. Scientists are learning that interstellar comets may be far more dynamic than anything we have seen before. Observing how 3I Atlas responded to sunlight, gravity, and radiation helps refine models of comet behavior and may even reshape our understanding of how materials travel across interstellar space. Every interstellar visitor is a direct sample from another star. That makes them like tiny treasure chests filled with information about how planetary systems form and evolve. Studying them allows astronomers to compare our solar system to others, giving a sense of what is typical and what is truly unique. 3I Atlas shows that even small objects can carry enormous scientific value, bridging the gap between distant stars and our own backyard. The comet's visit also sparks bigger questions. How many other alien comets have passed through unnoticed? What other chemical or physical surprises await in the vast stretches of the galaxy? Even as 3I Atlas recedes into the darkness, it leaves behind lessons about diversity, complexity, and the sheer unpredictability of the cosmos. In the end, 3I Atlas is more than a fleeting curiosity. It is a reminder that the universe is alive with variety and mystery. Its journey through our solar system has opened a door to new understanding, showing that the galaxy is full of chemical worlds, dynamic travelers, and stories waiting to be discovered. Every interstellar comet that visits brings a chance to learn, to rethink, and to appreciate just how extraordinary the cosmos truly is. Thanks for watching. See you in the next one.